Okay, guys. Today I'm going to be teaching you how to program um, user control in VEX Code V5. So this is for V5 kind of things. Um, so I'm going to teach you using kind of a theoretical kind of approach because I unfortunately don't have any V5 equipment at my house or a robot. Um, So I'm just going to be using like theoretical motors and theoretical, like a theoretical lift example, which should be able to get you through. So I'm going to split this into two parts, your drivetrain and then any other type of things you want to add on, because that's pretty relatively simple after that. So kind of the goal of programming, which is something that I always like to do at the beginning, is to kind of define what we want to do. So in this example, in this first video, we're going to do our drive, which means that we want to program the joysticks. Now, in a second, I'm going to pull up VEX code. We're going to initialize our stuff, and then I'll kind of show kind of an example using the joystick thing that it shows up there. The reason I'm not using VEX Code Pro V5 is that there's basically virtually no difference between one and another. Actually, VEX Code V5 is kind of nice because it's kind of got a built-in API of like different things that you can use built into it. And it basically uses all of the commands, the same library that VEX Code Pro V5 uses. For me, I use VEX Code V5 only because it's in my Chromebook, and unfortunately, Chromebooks cannot handle VEX Code Pro V5. Um, so essentially, instead of carrying a second laptop to school every single day I have robotics, I can just carry my Chromebook and I can still access the same file on both my Chromebook and my home computer, which is just an explanation. I used to use Xcode Pro V5, but then I found it mildly inconvenient because I was walking from one building to another and my laptop's pretty heavy and it just gets really confusing. So that's why I've kind of transitioned to using Xcode V5. Now, the way you access it on a computer, if you already have it downloaded, is you search up Xcode V5 within your system on Chromebooks. It's a little magnifying or like search key that you have on typically the left-hand side, at least for my Chromebook. If you're using Windows, you can use your Windows key. If you have Mac, probably the appropriate kind of key for that. I don't use a Mac, so I don't want to know. When you open it up, it's going to look like this. You have blocks also as an option. Um, If you want to use blocks, you can follow my VexIQ blocks tutorial. It's going to use the same approach essentially, um, just using a different system, but it uses the same types of blocks and everything. So if you want to do that, you can use that. But for once you're using V5, I highly suggest using text because there's so many things that you can do so much easier once you reach that level. And we'll be using C++. C++ is a slightly lower level, it's a lower level language than Python, meaning you have to write stuff a lot more explicitly. But what this will mean is that you're actually going to be running your code faster because it takes less time for the computer to understand what you're actually trying to say. I've never programmed in Python because I just started off with C++ and then VEX came out with Python. So I have never had a need to transition to Python because it was easier for me. I already knew how to use C++. I just suggest hitting C++ straight up because once you know it, there's so many things you can do, especially if you're taking AP Computer Science A at some point in high school. If you already know Java, C++ is literally so easy. If you have no prior programming experience, don't worry about it. I'll walk you step by step on what everything means for this regardless. Okay, you're gonna get a thing that looks like this. Actually, I realized I already screwed up because for VexV5, you actually want to use a template. If you read the manual, it'll actually tell you that you want to use a template. So you're gonna go over to File, Open Examples, Templates, and that's gonna give you quite a bit of options. We want to use a competition template because that's what VEX actually wants you to use. They basically tell you to do it because if not, you have to set it up, and if you screw it up, it's kind of like a oopsies, and you have to go through a lot of stuff and figure it out. And then competitions, your code won't run, and it's going to be your fault, so they won't let you restart matches or anything like that. So just use the template. Trust me, 10,000 times easier. No one's going to judge you for it. I do it. I'm a junior in high school. It's literally not that deep. So I have a big folder of all the stuff I do for my Google Drive. Store it in your Google Drive. Do not store it in your local drives, especially if you're on a Chromebook. If your Chromebook were to restart, you're going to switch Chromebooks at school, you're going to lose the file. Save it within this little Google Drive folder that you have. I don't care if you store it somewhere random, as long as you remember the name and you can search it. I have folders, which is pretty nice. So if I go to my clubs, I have a robotics folder. And then I have one for this year code. We're just gonna call it 2324 user control because that's what it is. Actually, 2324 over under, because it's the same code for user control as it is for autonomous in this scenario. If you're doing VEX v5, that's why I suggest you stick with these videos. If you're doing it, don't go over the block code, because if you go to the block code video, that's actually different because you don't use the competition template. It's the same principles, but it's not following a template because IQ doesn't follow that to begin with. So just save it, have your name. Next, what we want to do is initialize our devices. In this scenario, this VEX scenario, I have 4 drive motors. This is pretty standard for VEX. You might be using 2. If you're only using 2, basically you only have to do this twice instead of 4 times. We're just going to say 1, 2, 3, 4 for my motors. Right side is reversed. If you don't know what that means, I would suggest look at the end of my VEX IQ blocks programming video, part 1 for user control. It shows you how to identify if a motor is supposed to reverse it or not. If not, just test it out, see if it's like backwards or something. If not, it's fine. So we're going to go 1, so we're going to call it left front. And then motor 2 is going to be left back. Then we're going to call 3 is going to be right front. And if you remember, my right side is reversed. And then right back. Now, all of my motors are green in this scenario. If you have like a blue motor or red motor, just click the appropriate gear cartridge here. If else, just leave it the same. If you've watched some of my prior videos on how to do this before, I'll tell you to initialize stuff here using like the motor something motor and then like the port number and all of that. The reason I avoid doing that now is because I'm not switching between devices constantly or pasting it into a Google Doc. I can just use a file within any of my devices. And additionally, if you get to higher level robotics and you're using something called pneumatics, which are basically, the best way I can describe it to people is hydraulics using air instead of water. If you use that, the programming for that can get sometimes like you get weird errors for some reason trying to initialize it here. So I've just resorted to doing it here. And it's also pretty straightforward because you're writing less code, keeping track of less things, less room for error essentially. Another thing I forgot to add is a controller. You need a controller you're driving, pretty crucial. Controller 1 is just what it's going to default to. You can't really change that. But the code doesn't know that it exists, so you have to tell it it exists explicitly. So right now we have kind of multiple sections: pre-autonomous, autonomous, and user control. First, we're going to focus on user control because this is the main part of your competition. Probably the first thing you want to get done, and then work on autonomous later, which I'll be making a video later on how to do it. For user control, we're going to work on our drivetrain. If you don't know how to make comments by now, you might notice that there's like these green lines of code everywhere. That's a comment. Essentially, that means this. You can write anything within that comment and the code will ignore it when it's running. So yeah, there's 2 ways you can do it. You can do like this method, which is for multiple lines. I can like write multiple lines and then just cut it off by doing kind of the opposite. Or you can just do like a double slash mark, and it essentially does it for only that line. So I'm going to use this to define sections. We're going to call this our drive. This is just kind of how I format like headings and then subheadings and then lift. and then we're gonna, there's probably multiple parts and lifts, so we'll define those later. And then we also have to program our left drive, and then our right drive. Okay, perfect. Okay, back to the purpose of our program. If you look at our joystick, our controller, we have a nice little diagram. I have a nice little annotation feature within my screen recording thing. But essentially, we want to tell it that when we're at a neutral position, this means that we don't move. We're staying still. And then let's say we move our joystick forward, it's going to move our left side of our robot forward. And if we move our right side of the robot forward, it's going to move the right joystick forward, it's going to move our right side of our drive forward. And then if we move it in this direction, it's going to move it if we move the left joystick backwards, it's going to move our left drive backwards. And then same thing applies for this side. If we move the right joystick backwards, it's going to move our right drive side backwards. Yeah, that's essentially how it works. That's the best way I can explain it. The next VEX thing, if you've never seen a tank drive run before, suggest you watch my VEX IQ user control drive part 1. At the very end, especially the reason I'm talking about this is because I have a VEX IQ robot that I have access to record videos, and that one I actually demonstrate how it works. So if you want to watch that last part where it's like running and you can see the robot run, I suggest you do that. If not, and you understand it, then you're fine. So the left drive, the first thing you want to do is talk about how this works. Is basically you see these blue words all across our code, or these parts where it's before a period. That's basically what we're referring to, and then the period is what we want to kind of get out, like an action or something we get in return. VEX code V5 has these different things already set up for us. I wouldn't tell you not to look at them because they're pretty beneficial, especially if you forget. I sometimes refer to them to figure out what functions. For reference, these dot periods things are functions, or if you've used VEX, if you watch my VEX code autonomous programming, you'll know VEX calls them blocks. Those are things you're referring to. So I'm just going to write out a line of code, and then I'm going to explain what it means step by step. So it's left front dot spin forward controller 1 dot axis. I can never remember the axis. 3 dot position for PCT. Alright, percent. So essentially, this line of code talks about different things. Actually, in our motion tab, we actually have the exact same line of code somewhere. No, we don't. No, we don't. Okay, so this is telling our motor, left front, to spin forwards based on the position. Okay, so the way that VEX controllers work is that you can measure where the position is the axes in terms of axes 4, 3, 1, and 2. And this is really great because essentially VEX calls this position right here 0, this position is negative 100, and this position up here is 100. That means this position in the center is 50, this one's negative 50, negative 75, negative 25, negative positive 25, and then positive 75. You don't really need to know this as opposed to knowing that it's 0, 100, and then negative 100. So essentially what we can do is the controller has built-in sensors to know where the axis is. So basically what this allows us to do is to set different velocities based on how it is. So if we move our controller a little bit forwards, it'll move it slowly. But if we move it all the way, it'll move it at 100% speed. What's really cool about VEX as well is that it knows that if you set it to a negative value, it'll run in the opposite direction. So we can say it's forward, but then we give it a negative value, it means it's reverse. If we say that it's reverse and we give it a negative value, then it's forwards. So it's kind of like negatives times positives or that kind of thing. It's kind of that type of math. I would just suggest always leave things as forwards and then just kind of use negatives as reverse. It's easier to follow along. But yeah, that's saying, and then since it goes from 0 to 100, we can refer to it as a percent because percent means from 0 to 100. You can't go over 100. I wouldn't suggest you try to drive at 100% speed all of the time. So don't move your joysticks all the way forward like for more than 5 seconds. You're going to burn out your motors really fast. That's essentially what this line of code means. But we're only doing this for one motor, which means we have to do it for more. So left, back, spin forward, controller. So this is just referring to the controller that we're getting it from, because if you don't know this already, in VEX you can use more than one controller in a game. We're calling for the position of axis 3 on the controller, because this is our left hand side, so 3, and then percent. This is in terms of the unit. There's different units. You can set voltage. I think you can set like RPM on how fast it spins. But for now, I just suggest this. And then we also have to do this for the right side. Now, the major difference between this is that you're going to use a different axis. You're going to use axis 2, because if I pull up the graph in a second, once I finish this line, what you'll notice is that axis 2 is the one on the right side, and we want the right side joystick to control the right side of the robot in order for tank drive. Now if we do now we have to do the right back, which is essentially the same thing, because the same axis is controlling the same side of the robot. Therefore, we want axis 2 as well for this position. Now you can see why I kind of split it up. I misspelled position there. That's why. It's not brown. Now you can see why I grouped the left side and the right side together, because it's calling the same thing. This is essentially all of the code that you need for user control. You might be asking yourself, why is it in a while true loop? This means that it's running infinitely until something else tells it to do, something else happens. It's just running infinitely. And then the wait 20 milliseconds, this is to save resources. I can type. Because you don't want it to run infinitely, because then it's going to drain your battery, damage your motors. A ton of bad things will happen. This is essentially all of the code. Now you might be asking, oh, how do we tell it to stop running? Well, we talked about how this position is 0. So if it's calling for to set it to the velocity, or like the percent speed 0, it's essentially telling it to not move. That's why this works out. This is all of the code. So this is the end of the video. If you don't know how to upload code or drive, watch the end of my other video, part 1 for user control driving in VEX IQ blocks. The code doesn't matter, it's just the upload process is the exact same, and then also how to test and maneuver your robot is also the same. So yeah, that's how you code your user control drivetrain in VEX Code V5. If you're using VEX Code Pro V5, it's the exact same process. It's just going to be in night mode, and you won't have this nice little display on stuff. So yep, that's it.